Okay, welcome to this walkthrough of the test on similarity of similar shapes, including length, area and volume scale factor. I'm just going to try to explain the questions here. So let's start with this one, 12 to 16. We can see 12 to 16. So 12 to 16, I'm going to do this as a length ratio. So I know that can be simplified to 3 to 4. 12 to 16, 3 to 4. That's the small shape to the big shape. Well, look at this. We've got 15 there. So that's multiplied by 5. The ratio scales up by 5. So the missing length, QR, must be 20 centimetres. Nicely done there with the ratio. Here, well, we've got two options, and it's going to be 6 over 9 is x over 16. Small over large, small over large. So not that one, that one. With the third question, I'd recommend drawing the two triangles. Let's have a look. So we've got 4, and we don't know what that is. That's BD. That's what we're trying to find. Then we have the large one. Now that is 10, and that's 7.5. So I'm going from 4 to 10. Well, you can do this with scale factor. So your length scale factor is multiplied by 10 over 4. Well, that's the same as multiplied by 5 over 2 or by 2.5. So something times 2.5 gives me 7.5. So this missing thing is how many 2.5s go into 7.5? Well, it's 3. So it's 3 centimetres. 3 times 2.5 gives me 7.5. So I just drew the triangles, worked out the scale factor, and saw what I needed to multiply. So essentially it's 7.5 divided by 2.5. You can do that with the ratio as well if you wish, but I've just done that with the scale factor. Next page, next question. There you go. Now, two mathematically similar shapes have a volume scale factor of 64. What's the scale factor of length? Well, volume scale factor is 64. Now to get length scale factor, I cube root that, which would be multiply of 4, a length multiplier of 4. So I'm converting 0.9 meters cubed to centimeters cubed. Well, meters to centimeters is multiplied by 100. So meters cubed to centimeters cubed is going to multiply by 100 cubed. 100 cubed is actually the same as a million. That's got 2 zeros, that's got 6 zeros. So 0.9 times 100 cubed would actually give you 900,000 centimetres cubed. Just remember your meters to centimetres, and then we cube the conversion rate. Here we've got 2 to 6. Height of 2 to 6, we've got a length scale factor of multiplied by 3, but we're comparing the area. So the smaller ticket is 7 centimetres squared. What is the larger one? So area scale factor is multiplied by 3 squared, same as multiplied by 9, of course. So multiplied by 9, 7 times 9, 7 multiplied by 9 is 63. 63. So the length scale factor was 3, so the area scale factor was 9. Here we go. So we've got another one where you've got two triangles. If I were you, I would be drawing this out, draw them separately, 7.5, 10.5. My smaller one, imagine that flipped over. So that's 2.5 and that's 6. So that actually multiplies by 3. Small to large, we've got length scale factor of multiply by 3. 2.5 to 7.5. You just flip this top one over. These ones are similar, and those lines are parallel, by the way. So we need to find DE, which is this one. DE, which is the base of the large triangle. So 6 centimetres times 3 equals 18 centimetres. So that base there would be 18 centimetres. 18 centimetres. Right. On to the last page. Now, we've got volume here. So, but we're dealing with length first. So the length scale factor. These numbers aren't very nice. This is very much a calculator question. So the length scale factor is 15 over 12. Well, I could simplify that. Divide that by 3. So I've got 5 over 4 or 1.25. We'd be using our calculator really for this. Volume scale factor is going to be multiplied by 1.25 cubed. And in your calculator, you would probably want to do here 1400, which is the volume of this, times 1.25 cubed. 1400 times 1.25 cubed. And with the benefit of a calculator, I can tell you that that would be 2734.4 centimetres cubed. And that's just to one decimal place. I've done that too. So I found the length scale factor and cubed it to get the volume scale factor. Here we have the surface area, so we can work out the area scale factor. So the area scale factor between these two, because we've got both areas, is, well, I can call it 12 to 75, can't I? Because I've got area scale factor of 12 to 75. I can simplify that, I believe. 4 to 25. So that's in ratio form. So I've gone for ratio form. 120 to 750, 12 to 75, 4 to 25. So the length scale factor ratio in ratio form, I just square root that. 2 to 5, but I'm dealing with volume, of course. So the volume scale factor, because they're nice numbers, I'm just looking at the ratio, 8 to 125. So I've got 8 to 125. Now, what's less nice is the number we have to deal with. So I'm saying, well, if that's 8 to 125 as my volume ratio, they're going to be the volume of A multiplied by 125 over 8 equals the larger volume of B, which is 1600. So if the ratio is 8 to 125, the scale factor is 125 over 8. So I need to work out the smaller one. So I'm going to do 1600 divided by 125 over 8. And I mean, for this, you can use a decimal, really. You can say, well, what do I do to get from 8 to 125? Think of a decimal, get the decimal from your calculator and use that. I'm just showing you the ratio here. So let's have a look. With the benefit of a calculator, again, I can tell you that's 102.4 centimetres cubed. So let's just look at what we've done. We know the area scale factor, or the area relationship, it's 4 to 125 in ratio form. So I square root that to get the length ratio. I cube that to get the volume ratio. So I'm square rooting, then cubing. Very common type of question though. Let's look at the last question. Well, we've got volume scale factor there, and we need the ratio of the area. So the volume ratio is 12 to 96. 120 to 96. Well, 12 does go to 96 quite nicely. 1 to 8. So that gives me a length ratio. What do I do with the ratio? Well, I cube root. So it becomes 1 to 2 because I cube root. And now the area ratio, which is what I want, I square that to get 1 to 4. 1 to 4. So it wants me to get the ratio of the surface area of A to B. I start with the volume relationship, which I'm given, which is 120 to 960, 12 to 96, 1 to 8. I cube root the volume to get the length ratio, and then I'll square it to get the area ratio. I hope that's all clear. I know I've gone through it a little bit quickly, but feel free to rewind and go back and check anything I've done. Thank you.